Hello, everyone, and welcome to another episode of Containers from the Couch. My name is Cy Venom, and I'm your host for today. I want to start with an analogy. Imagine you're taking a cross-country road trip, but you're only equipped with tools from the 80s, like a map, a paper map, and a compass. Sure, it might seem like an adventure, but I bet you'd be more comfortable if you had tools like real-time GPS, traffic updates, and weather updates. Well, essentially, that's what observability comes down to. It's not just a buzzword, but a real approach to making sure that you can navigate a complex application architecture, such as one that might be deployed on Kubernetes as containers. With that, today I want to introduce my guests. They're speakers from AWS, experts in the observability space. Imaya, I want to start with you with kind of a general question. In your words, what's kind of the importance of observability, especially in the context of Amazon EKS? And please also introduce yourself and tell us a little bit about what you do at AWS.
Thank you, Sai. Hello, everybody. It's a great privilege to be here. Thank you for inviting me here today, Sai. And it's always exciting to talk about observability. My name is Imaya Jaganathan. I'm a principal solution architect. I focus on observability here at AWS. Observability has always been critical. We might think that it's a word that is becoming very popular these days, and it's probably a new kind of a domain that is that's getting very popular or anything like that. But it's not really the case. It's always been important, and anybody who's been operating any kind of environment always wanted to know what is actually happening in their environment, whether it is a simple client-server application or a web application or anything like that. You really want to collect information from your application performance, health, and whether there are any errors. The logs have always been one of the signals where you would see errors and so on and all that stuff. But now that customers are architecting applications in a much different fashion with all the microservice-based architecture that's out there, really highly ephemeral environments that are being spun up using container technologies like Kubernetes, EKS, ECS, and so on, and even serverless like Lambda, it's very important for customers to know how their applications are performing. So now we also have lots of different signals to collect. Like traces, for example, which gives information about the service-to-service interaction, how a request from a customer from one service goes to a service A to go to service B and service C and so on. So you actually get a whole picture of what's actually happening in your whole application. And it's really important, right? And there are different types of signals today, like traces, metrics, and logs. And it's very important for customers to kind of correlate all this data together to make sense out of what is actually happening. Because in these different signals, you actually get different kinds of data. And when an issue happens, you would want to be able to quickly get to the root cause so you can give all the necessary information to the developer, or maybe equip the developer to basically go get all the information immediately. So he or she can start working on a fix, rolling it out, so customers are not impacted. So it's all about satisfying customers. If you want to satisfy customers, you want to operate a healthy environment. To operate a healthy environment, you need to know what's healthy or not healthy looks like. So that's what it is in a nutshell.
Thanks for that quick overview of observability. I know we're going to go more into depth here. We've got a demo lined up for all of you today, as in traditional containers from the couch. That's the way we do things here. Next, I do want to go to Mikhail. Mikhail, tell us a little bit about what you do at AWS. I know we've had you on Containers from the Couch before, but just as a refresher. And also, I have a more specific question for you as well. When we think about developers working with observability tools versus operators, the context there is different. Tell us a little bit more. Can you talk to that a little bit more as well?
Oh, for sure. Thank you, Sai, for having me. It's definitely a pleasure, always a pleasure to be on the Containers from the Couch. I'm a principal solutions architect on containers and app modernization initiatives primarily. I also go a little bit wider, cross-functional into cloud management, security, and other areas to basically build solutions. I primarily work with our partners, so it's consulting and ISV partners, but I'm also a contributor to the EKS Blueprints project, a number of other open source initiatives. I can wear different hats, both as an architect, as a developer, as an engineer. So it's a little bit, it makes it a little easier for me to talk about those aspects. So when we talk about developers and different categories of personas in the context of observability, it kind of makes sense to tailor those solutions to the target audience, because developer perspective of observability may be quite different from the operator or from a platform engineer, for instance, perspective. And because of that, we try to make sure that the solutions that we build are consumable for all of them. So as a developer, I would be probably more interested in my particular workload and metrics related to that, rather than the health of the infrastructure as a whole. I would be interested in ability to troubleshoot performance issues. That's probably, I mean, generally bugs it's easy for developers. They just get a log, fix it. The problem occurs when there is a performance issue, latency becomes bigger, and visibility into those aspects is extremely important. And that's what we're trying to achieve with the tooling that we offer, both from AWS and from the open source community.
Excellent. Thank you, Mikhail. And as we go through our session today, I'm going to pick on you a little bit and ask you to elaborate a bit on whether the piece that we're going through is more dev-focused activity or an ops-focused activity. And I know that when Ela shows his demo here in a minute, we're going to be covering both aspects. So it would be good to get a clean view into who should care about what piece. And so with that, Ela, I want to pass it to you again. Tell us a little bit about yourself, what you do at AWS. Again, I think you've been on Containers from the Couch before as well. But Ela, give us a sneak peek into the demo that you're planning to show us today.
Yeah, absolutely, Sai. And it's such a pleasure to be here. It's third time here. Third time is a charm. So happy to be here. Yeah, so myself, Ilamaran Shanmugam. I go by Ela. I'm a senior container specialist solutions architect with AWS. Observability and resiliency on Kubernetes is also my focus area. So with respect to what I do with AWS, I work closely with the ISVs and SI partners. So I help them architect on the cloud with Kubernetes and EKS, and also take part in app modernization initiatives as well. So with respect to today's demo, I mean, customers do fall into the trap of too many different choices in AWS to do observability, right? So we have AWS native choices like CloudWatch. We have open source choices like Amazon managed Prometheus, Amazon managed Grafana, OpenTelemetry. So in this demo, what we're going to see is a quick sneak peek of, you have an existing cluster. How do you set up observability in 5 minutes? Yeah, just 5 minutes. So we're going to show you how to set up observability with open source services like Amazon managed Prometheus, Amazon managed Grafana. And we're also going to talk about how different personas can think about what they have to do. Like for a SRE, they're going to focus on creating dashboards without coupling their activity with key infrastructure creation. So platform architects can focus on creating the platform infrastructure with EKS. So we're going to see that differentiation. So we're going to see that in demo live with respect to open source pattern. And then we're also going to see a sneak peek around the architecture around how we are going to deploy that. And then we will also be seeing in detail around an AWS native pattern on an existing cluster that I've deployed and how the logs are flowing into CloudWatch and how we are seeing the metrics using Container Insights. So that's going to be our focus of this demo for today.
Excellent. Looking forward to that. But before we get to the demo, I think we need to do some groundwork here. Imaya, I've got a question for you. Now, I know that when we talk about observability, there's a large scope, and there's open source tooling available, as well as AWS managed services, and these sometimes work in concert. Every customer can kind of be seen as a unique snowflake. No customer use case is exactly the same. Imaya, talk to us a little bit about observability, how we're positioning it, and notably the fact that we're talking about something new today, right? And it's something new that we built in open source. And I think that was a choice, a very intentional choice that we made. So Imaya, tell us a little bit about what's new and a bit more about the space.
Sure, absolutely. Before I answer that, I just want to highlight on why customers love managed observability solutions, whether it is on AWS native side with CloudWatch, X-Ray, or with the managed open source side, which is managed Prometheus, Amazon managed Grafana, or even Amazon OpenSearch service, right? And the reason is, yeah, of course, customers we talked about the signals, about metrics, logs, and traces, and all of that before. Yes, you collect all the data, and you want to collect all the data, and what do you do with the data, and where do you keep the data, right? There are a lot of open source projects, and there are many solutions that you can actually use to operate a big environment where you can ingest all these data and keep them and provide an infrastructure where you can query all this data and so on. But there are more and more customers who are operating internet scale applications today. So it's really common with the advent of cloud, everybody is capable of operating such large environments. So which means they are generating a tremendous amount of data. That means you have to provide and provision and keep up and running a large scale infrastructure that is highly available and secure and all that stuff, which becomes complex. So that's why customers more and more increasingly talk to us about like, how can you help me to offload this heavy lifting that I have to do on day in and out basis, which is really not a workload that I want to consider critical because I have line of business applications that I want to focus all my energy on. But this becomes more critical than all of that, because if I lose this, I lose visibility on my applications, on the business applications. So so that's why customers choose CloudWatch or Managed Prometheus service and so on. While I say this, yes, there are many instances where it is really easy to kind of like simply, deploy something and have your metrics or logs get collected to manage. But one really good example is CloudWatch Container Insights, which we launched back in, I guess, 2019, which really allows customers to very quickly collect metrics and logs from container environments, such as ECS, and even specific workloads like Java, JMX, or Nginx, and HA proxy, and so on. It gives an opinionated dashboard and collects specific metrics and logs, and gives a console interface to go filter and do everything with just very little work. When it comes to the managed open source service, customers love Managed Prometheus, and particularly Kubernetes customers. It's really a great marriage between Prometheus and Kubernetes there, because Kubernetes exposes metrics in native Prometheus or Prometheus exposition format, and has really robust service discovery that Prometheus leverages out of Kubernetes. And a lot of Kubernetes customers, EKS customers, love using Prometheus. And when we launched the Managed Prometheus service, yes, we offer a remote Prometheus metric storage solution, a long-term storage solution that allows you to store a tremendous amount of volume, like up to 500 million in a single workspace today, 500 million active time series in a single workspace today, and manage Grafana to visualize all of that and alert all of that. And you can use OpenTelemetry Collector to collect the data and all of that stuff. So now I already mentioned too many service names and too many stuff here. So that's exactly the challenge that customers were facing, because when conversations with customers, which I talk to hundreds and hundreds of customers every year, customers were asking, okay, how can you help me, get from point A to point B quickly? Because you are asking me to do a lot of things to me for me to get there. I see obvious benefits in using Managed Prometheus and Grafana and OpenTelemetry, but it's too much for me to design and all of that. Do you have an opinionated way to do this? Can you make it easier? And we looked at for inspiration, we looked at CloudWatch Container Insights, and yeah, so we have a solution. We did solve this problem with CloudWatch. So why not build something that is that basically does something very similar, but also is open source, so we can scale faster, we can develop publicly, and we can get a lot of inputs actively and start delivering for customers and solving the problems. So that's when we started with the Terraform accelerator, so which we launched in somewhere last year, close to last year. And what we did with that was, I don't know if you're sharing my screen already, I can probably show that. What we did with that was we created a public GitHub repo, and we started working on it, and we launched a fully automated solution that customers simply can just clone and then follow a set of instructions and have observability ready just in a couple of minutes, right? What it does is it essentially uses, maybe zoom in a little bit more, it uses the operator for EKS, and the custom resource that the operator manages is the OpenTelemetry collector, and all of that is deployed automatically from this Terraform Observability accelerator. It will deploy the enable the add-on, which for the operator, deploy the custom resource. It will configure the OpenTelemetry collector to scrape the metrics, and it will deploy a lot of recording rules and alerting rules that are relevant for monitoring, and also optionally also deploy a lot of dashboards for into the managed Grafana workspace that you point to, right? And this makes monitoring very easy. From having nothing, just by cloning and following a couple of instructions, and within a few minutes, maybe 2 to 3 minutes, you will have fully monitored cluster there. So you will have full information about like how your EKS cluster is doing and so on. So this is essentially, like I mentioned before, an inspiration from CloudWatch Container Insights. So we also built, in addition to that, we also built additional capabilities into this. We built support for multi-cluster monitoring, Java, JMX, Nginx, Istio, and so on, all based on customer ask. And we also can support tracing. Like we can customers that are tracing their applications, collecting traces from their applications, can use this module to collect traces into X-Ray. Then what we did is while we did this at AWS, as we all know, we listened to customers and we basically build what customers are asking for. There are a lot of customers who are asking for, this is Terraform is great, we love it. What about CDK? Because CDK is just so popular amongst developers in particular, because it allows you to develop infrastructure code in a high level language of your choice. TypeScript, starting with TypeScript, now customers can use Python, Java, .NET, and I think there's also Go support, which is in preview right now. Customers love the fact that they can use a familiar language to provision their infrastructure. And CDK requests started coming in, then that's when we started working on it. Ila essentially spearheaded a project and basically built something that would kind of in some ways mimic what we did with the Terraform, the version of the project. And it does very similar things. It basically collects metrics and traces also from EKS cluster, and it does some more interesting stuff as well. It can also do it is AWS native specific. Like for example, you can even enable container insights using this. You can have the OSS version with which you can use the this particular module to deploy the OpenTelemetry collector to send metrics to Prometheus and enable Grafana and send traces to X-Ray and so on. And you can also have a mix of both as well. So there's lots of stuff. I know Ila is going to get into the details of this. But what we're really excited about is the fact that this is all open source, like you mentioned before. This is all out there on GitHub, and we actively have customers using both Terraform and CDK. We have thousands and thousands of clones, and we have customers giving feedback, creating issues, and we even have customers who are contributing on GitHub, so which is quite exciting for us, which is exactly what we wanted to do. And this is great to see that it's all coming into place. And like we always like to say, feedback welcome, and basically customer input is what we always listen to, and we want to build based off of that. And if there are any issues, any inputs that you have, request customers to create an issue on the so we can work on that.
Awesome. Imaya, you're answering my questions before I have a chance to even bring them up. So that's really great. I do have kind of a more basic question though. For our viewers that are watching, a lot of these kind of complex architectures you're showing, the claim that we can get this deployed in 5 minutes, a lot of viewers might be thinking, oh, so this is a sample app. This is an architectural example of what could be done. But it's much more than that, right? Can tell us a little bit more about how customers can actually use this today, not just for POC or greenfield applications.
Right. Yeah. So this is just a POC. So it can. We're not only just giving a blueprint and asking you to tweak and kind of go build off of it or anything like that. We are basically delivering something that is actionable. Customers can take this and really use it in an actual production grade EKS cluster, for example, right? So we do have customers who are able to make use of this just like that, or maybe sometimes they had to make a few changes here and there, but they were all minor changes, right? So sometimes they had to maybe optional, keep certain features optional. Say, for example, like I don't want to have certain dashboards, so maybe they just wanted to remove certain dashboards from there, or maybe they wanted to add some extra dashboards and stuff like that. Those kind of smaller changes. Customers are welcome to use it in any environment that they want. However, they also should remember that this is open source, and they can take this and really tweak and customize as well if that is the need, which is exactly what we wanted to get to. We don't want to deliver something that customers don't have lots of ways to kind of tweak and change and leverage their own in-house expertise as well. So in this case, we are not only taking them from point A to point B, but if they want to, point B is not the destination, if they want to go further than that, they can take it and tweak and go wherever they want to go to.
Awesome. And we mentioned the notion that we're giving folks opinionated approaches, opinionated modules, but it's a fine line that we need to tread here, because there are pieces where we want to be opinionated, and there's times where we need to listen to what the customers are asking for. Mikhail, I had a question for you regarding that kind of opinionation, and especially with your focus on EKS blueprints. How do we tackle that challenge of where do we draw that line of leveraging open source tooling versus managed services, and then giving customers the ability to plug and play with their own, maybe partner solutions as well? How do we resolve that?
That's a great question. So for the EKS Blueprints initiatives, we started looking at the real problems that customers were facing, and partners as well, especially related to the complexity of managing EKS or Kubernetes-based systems, with observability being a very important aspect, obviously, along with other aspects. And it became clear that the number of permutations how it can be used is just it's quite huge. So it's not possible for us to come up with an opinionation that will satisfy everybody. So instead of creating an opinionated solution, which is somewhat similar to a PaaS, platform as a service, like in the past, and those systems, we know they didn't really fly that far. I mean, there was a rise and fall of those. So in order to avoid those mistakes, the focus for us is on extensibility and ability to apply any type of changes that customers want to have and achieve solutions that they want. And we are focusing on just creating the building blocks, like Lego blocks, that you can simply just put together in a very simple manner and create a working solution that will be stay at enterprise scale, etc. So you can take a look at, for instance, any common solution like internet scale applications. That's what the mindset customers are currently running. A lot of them know how to operate it. It starts with an overall blueprint for their cluster that has to be performance optimized. If you are running hundreds of nodes or thousands of pods, etc., you start with that layer, and on top of that, you can apply your observability solution. We provide a few common patterns, which may map to 80% of cases, with a full extensibility support from the EKS blueprints to apply any customizations, both to observability or any other aspect, such as security, such as, you have compliance, you want to have policy engines on top. At the end of the day, we should really focus on, okay, observability aspect is applied. What next? We need to run workloads. We need to make it more production ready. And all of those components to extend it are coming with by the benefit of using EKS blueprints. And that's the case both for the Terraform version of the accelerator, as well as for the CDK version, with just slight variations of maybe the target audience or preference for tooling. People like Terraform, it's hugely popular. There are people who like programming languages to define those aspects as well. So from that perspective, I'm thinking that less opinionation, or opinionation where it makes sense based on the actual evidence, paid off. But the extensibility is whatever you guys want to get, you will be able to achieve, and it goes well beyond the observability concern as well.
That makes sense, Mikhail. We do have a question coming in chat from Murali. What about the cost for implementing this solution in EKS? And is it different from the add-ons model that we have in EKS blueprints?
So the add-ons, we use that term, and it's important to probably clarify something here. So the add-ons is an overloaded term, and we use add-ons for EKS, what we call core add-ons. Those are going to be like kubeproxy, core DNS, VPC CNI, as well as the marketplace add-ons, which enable our partners and third parties to create add-ons that will be integrated with EKS. That's a relatively new wave of add-ons. And then we also have blueprint add-ons. Blueprint add-ons maybe marketplace. We have blueprint add-ons for the core. We don't really limit that abstraction to anything in particular. So the cost of the solution is not going to be any different because the tooling that we provide is open source. You're free to use it. You will just save time on getting to market, which is the whole objective of this initiative, allowing our customers to focus on the value-add activities rather than dealing with those concerns that we solved for them based on our experience. Depending on the partner solution, however, we also have partner add-ons, and it's important to mention. We have an add-ons on the CDK EKS blueprints. We have add-ons for Datadog, for New Relic, for Dynatrace on the observability space. We also have an add-on for KubeCost if you want to really take a look at the cost of the solution itself. And those may be governed by their own licensing terms. So definitely customers can pick and choose. Of course, as AWS solutions architect, we're going to focus on AWS first, whatever we have in stock and we maintain. But the options are there, and some of them are definitely paid.
Right. So I just want to add one point to what Mikhail said. This is, this is open source. So what customers can do is they can just tweak if they want to reduce cost. Like, for example, let's say take a quick example of managed media service. The way we charge is for the major cost is the ingestion cost, like the number of metrics and how frequently you're sending the samples against those metrics. And customers can go tweak the scrape configuration, increase the scraping interval, or maybe just drop some metrics, and so they can just get rid of some dashboards maybe that they don't need and all that. So the thing is, the cost can vary based on what you're deploying and how you're configuring. So you have full freedom to go experiment in a lower, non-prod environment. That's what we would highly recommend. Don't go just jump directly into prod. I'm hoping that most people would not do that. Test it out, check it out, and see how many metrics it's collecting, whether those metrics are useful or not. But just go and change it. So there's no way, like Mikhail mentioned before, there's no way for us to give something that works for everybody. That's absolutely not going to happen, right? So that's why it's open source, and that's why it's changed, tweakable. It's nothing proprietary here. It's typical Prometheus configuration. You can go drop metrics, add metrics, and group them and do whatever to reduce cost.
Right, exactly. No one solution is going to fit everyone, essentially. And what we've done here is pull together a starter, at least, with all of the tips and tricks that our experts here have picked up from working directly with customers, and put them in one open source project. But I must stress that most customers, when using this, they're not just pulling it right off the rack. They're forking it. They're pulling it down. They're making the edits to fit their necessary requirements. But I think we've covered the background here. Ila, I want to jump to you. Let's jump into the actual demo and see how the observability accelerator works.
Absolutely. I hope you folks can see my screen. So this is the primary repo of this solution that we have been talking about for the last 30 minutes. So here is where we have our code, and this is fully open source, and everything is all here. And this is the URL. I mean, the URL can be found right-clicking here. So this is the URL which we were talking about, like Imaya was presenting. So this URL has the documentation around different patterns we have. Let's say you have an existing cluster, you want to deploy an AWS native pattern or an open source pattern, or you want to set up a new cluster and then set up observability. So I mean, we have different options for you to pick and choose. Like let's say you want to set up a EKS cluster with Grafana nodes and then 64 nodes, and then also set up observability in 20 minutes. That is also possible. So as I said, right, to start with for today's demo, we are going to focus on setting up open source observability on an existing cluster. So I'll just start with running the deployment, because the deployment takes 5 minutes. And then in the meantime, I will just continuously and constantly explain around the architecture and what are the things that's happening under the hood. To start with, the first thing we need to do is clone the repo, which is something we all know. So what I did is I just cloned the repo. And then the next command we have to do is just run make deps. And obviously, since it's a CDK and we are using TypeScript, we need to have Node installed. And then we also need to have npm, the Node package manager installed. And those two are the prerequisites. And then just do a make deps. So what that particular make command is going to do is it's going to install the prerequisites, and it's going to do an npm install and get the environment ready. And then the next thing we have to do is do a make build, and we have the underlying script for that in the make file. So what make build is going to do is it's going to create the destination directory with the runnable code for CDK. And then next is the command make list. So this is one of my favorite commands, because this command is going to show you that what are all the different patterns that we have with this solution, rightly aligning to the website that I was showing you, right? Like we have all these patterns, and you can see a exact replica of the different patterns that we support here. And then obviously the next command is we wanted to deploy the existing open source observability pattern. But before I do that, let me show you the cluster that I have. So I have just a bare bones cluster that I created right before. If I just do a kgns like kubectl get namespaces, what I'll see is you see, right, the cluster has pretty much nothing except it is running just the kube system and kube nodes, and then obviously it's just running a node exporter, which is basically a mechanism to export node metrics, right? And that's it. We pretty much have nothing. It's just a bare bones cluster. So count my thing. It's going to be next 5 minutes. You're going to have completely observable cluster, which means that we're going to install AWS distro for open telemetry. We're going to set up Amazon managed Prometheus, and we're going to also use Amazon managed service for Grafana to create Grafana dashboards, Grafana data sources with AWS services in just a matter of 5 minutes. So let's get that in action. So the command here is make pattern existing EKS open source observability. That is exactly the name right here. And then what you do is just do a deploy. And then it's going to prompt you to say, are you okay with deploying this in another 20 seconds? And then you're going to say yes for that, and then yes, it's going to start the deployment. So let the deployment run here. It's going to take another 4 to 5 minutes. So in the meantime, let me explain the architecture that we are really deploying here on a bare bones cluster. So as I flip back to this website, as I go into the open source software page, and this is exactly the this is exactly the solution we are deploying currently. So what it is doing is, think about this architecture as deployed by two different personas. One is the platform architect, who is concerned about deploying the EKS cluster with all the day-to operational tooling that Imaya was pointing out, like AWS distro for open telemetry, Grafana operator, Amazon, setting up Amazon managed Grafana, all those things. The platform architect is focusing only on setting up the infrastructure that is required to run your workloads. The second persona here is the SRE, the site reliability engineer, or you can even call it a developer of that particular workload, right? So what the developer or the SRE wants to do is he wants to see the dashboards of real-time monitoring that is happening. So in this solution, what we have done is we have decoupled the infrastructure part and SRE part. So as the solution is deploying, let me talk about the SRE part. So we have a separate repo called GitOps repo. So the GitOps repo is where the GitOps code is currently housed. So if you see the solution, we have Flux. The Flux is set up to sync with the GitHub repo, and that is this repo. I'll talk about what is there in the repo, but fundamentally what's happening here is Flux is syncing the cluster with the repo, and then it is deploying the resources on Amazon managed Grafana using Grafana operator. So what Grafana operator is really doing here is it is using Kubernetes as a control plane, and we are using an external managed Grafana as a data plane. And Grafana operator is creating an identity between the Kubernetes cluster and the external managed Grafana, which is AMG in this case. And then it is creating data sources, it is creating dashboards, all using Kubernetes native way, like Kubernetes resources. So for example,
Let me see if I can get that right before you move on. So essentially what you're showing, what you just kicked off, is something that a platform operator would do. So they spin up the CDK or Terraform, and everything is getting deployed. We've got the GitOps, we've got the source of truth in Git. But you're saying that as an app developer who wants to create app-specific dashboards, they don't need to know anything underneath the covers. They don't need to know which Prometheus or managed Grafana tools being used, the authentication credentials for them. They don't need to know that Flux is being used to pull YAML from Git. All they need to do is deploy their app-specific dashboard, at least the YAML that defines it, into Git, and then expect that the rest is taken care of for them. Is that right?
Absolutely, you got it 100% right, and thank you for exactly recollecting that. Right. Let me jump that with the code. Right. Just take an example here. You see here. I mean, consider yourself as an SRE, right? You don't need to really care about the platform architect. But what you wanted to do is you wanted to create a dashboard by name Node Exporter. So you wanted to use Node Exporter to export all the node metrics that is coming from the cluster. But you see that the platform architect has not done that. So what you do is you just create a YAML like this, pointing to the Node Exporter JSON, which is the Prometheus, the Amazon Managed Grafana JSON standard, right? You're just creating a JSON of the dashboard format, and then you just submit a Git pull request to this GitOps repo. And once the approver of this pull request approves this particular pull request with a new dashboard, which the workload developer wants to see in Grafana, and that's it. The Flux is going to automatically sync that new dashboard into with the Flux, and Grafana operator under the hood is going to do the magic of deploying this dashboard YAML snippet. And then obviously once the YAML snippet is deployed, automatically this particular JSON is going to be represented as a dashboard in Amazon Managed Grafana.
Excellent. So I know we were doing an observability demo today, but as a bonus, we're getting the masterclass in GitOps as well. And I think this is actually one of the cool things about GitOps is that it's a pattern that's applicable for so many different use cases, and observability is no stranger to that. It also benefits.
Absolutely, sir. And the important thing we need to highlight here is till Grafana operator is a CNCF project. It's an open source project, right? But till Q3 of last year, there was no mechanism for Kubernetes cluster to access an external managed Grafana. So what we from AWS did is we worked with Grafana operator CNCF open source project. We built this integration with the CNCF open source Grafana operator team to access external Grafana, which means that any cloud provider have a Kubernetes cluster can deploy Grafana operator to access their external Grafana. So this is basically our commitment to open source, right? It's not just we are building services to enable our business from AWS side. We are also contributing to open source for a larger goal. This is one classical example of that. I just want to iterate that. And then also want to talk about this architecture. It is really well architected. If you see, we are using external secrets and we are storing the secrets of Grafana, Amazon Managed Grafana in a systems manager. We are also cost conscious. So we are using systems manager, which almost comes with no cost, to store the secret of the Amazon Managed Grafana. And then we are using that for Grafana operator to create an identity between the Kubernetes cluster and Amazon Managed Grafana. And then we are using GitOps, like you said, Sai, to deploy those dashboards in a Kubernetes native way. All right, so I hope I tried my best to explain the architecture. Let's go back to the console. Okay, it's like 252 seconds. What it is, 4 minutes and 12 seconds. The cluster is completely observable now. Within 4 minutes and 12 seconds, your cluster is observable. Previously, you had nothing in the cluster, but now you have complete observability on the cluster. Let's check that out. So yeah, you see here, I deployed Grafana operator, I deployed Flux, external secrets is deployed. Let me also run some few Grafana commands before I show the Amazon Managed Grafana console. Yeah, see here. So I have created an external Grafana. So what this means is this resource, this custom resource is creating an external identity between Kubernetes cluster and Amazon Managed Grafana. And then let's also see something else. So what you see here again is we have created 3 data sources for Amazon Managed Grafana from your Kubernetes cluster. So what this means is we are using a Kubernetes native way to create a data source on an external Grafana instance which was never done before. And then the last but not the least is the fun part of dashboard, which is what Sai was asking, right? So using GitOps repo, the developer or the SRE has submitted a new JSON file. So what's happening here is we are using a Kubernetes native way, using the Grafana dashboards custom resource to create a dashboard on an external Amazon managed Grafana from your Kubernetes cluster, which means you're using your Kubernetes cluster as a control plane, and with GitOps approach, pushing your YAML code and pushing your JSON code, and you're directly creating the Grafana dashboard. So within 4 minutes, right? Which is really awesome. And as a matter of fact, we even deployed this to a customer right today, and they were really delighted, right? They had a cluster in production with absolutely no observability, and within 4 minutes, we had these dashboards created out of the box. So that's with respect to the resources in the cluster. Let's jump into action with respect to the console. I want to show you a quick peek of these dashboards in console. So this is the, I already have an entity open. Okay, here we go. So if you see here, right, if you go to the data sources, I didn't do pretty much nothing, but the data source is already created, right? The data source is already created and it's already working fine. And then if I go to the dashboards part of the Amazon managed Grafana, and by the way, this is the Amazon managed Grafana console.
Eli, it's a bit small, by the way.
Oh, I'm sorry. All right. So it creates a folder called Observability Accelerator Dashboards automatically with the YAML snippets I was showing. And then let's click on the kubelet. So basically, you see within 4 minutes, your cluster is observable, and you already have a Grafana dashboard setup created. There is a tight time between your cluster and the Grafana, Amazon managed Grafana, and you also see metrics flowing in 4 minutes. So you have a cluster observable in 4 minutes, which in the past used to take days and weeks, right? So that is the beauty of the solution. It's completely opinionated, though, but it is completely out of the box solution, right? Like few commands on existing cluster, it's completely observable. So you can see all the metrics going from kubelet, right? Like you can see the number of pods running, the kubelets, I have a single cluster. That's why you have 33 containers running, you have volume count, and so on and so forth. And you also see metrics around the pod start rate, pod duration, operational duration, so on and so forth. Let's see another interesting dashboard here. Next. Node exporter.
I do also want to call out here, Ela, really quickly that there's an entire ecosystem of Grafana dashboards that have been uploaded by the community as well, right? So even if there isn't something exactly aligned to what you need here, you can always leverage the really strong community of Grafana dashboards that are out there as well.
Yeah, absolutely. So all they have to do is just take a JSON of the community dashboard and just supply that as the snippet in your GitOps repo, and that's it. Boom! It's going to start creating those Grafana dashboards. Yeah.
And real quick, the benefit of doing that in Git rather than just clicking the buttons in Grafana. Can you talk to that a little bit?
Yeah, absolutely. So there are two things, right? The first thing is if you're using click options in Grafana, the problem is that you're going to have the user manage the user identity. So in a real production environment, your developers are not going to get access to an Amazon managed Grafana to create dashboards, right? That's one fundamental thing. The second important thing is it's all a lot of manual work, right? Like you have to just copy the JSON, get it here, give the IDs, setting up the environment. So it's like a lot of manual work, and also creating the access policies and setting up those access policies is pretty complex. And also the maintenance of that is also cumbersome. Let's say you want to make a change to the JSON, you're going to again go do the manual process that we used to do in the past, right? So those things are really going to make it really challenging for the SREs and the developers. But on the flip side, what we're doing here is, without even experimenting in production environment, like if there is a JSON error, what do you do? Like if the dashboard is not going to work, right? Without any of those experimentations, what you're doing here is you're just submitting a pull request to a GitOps repo. So what's going to happen with this approach is you're going to have a senior person who's going to review the pull request. He's going to come up with some errors. He's going to tell you, hey, there is a JSON error, fix it. Or you can also map the branch of your code into a test infrastructure, and also you can test it out, right? But fundamentally, what I'm saying here is GitOps enables you to better pair program, and also it enables better developer collaboration rather than like he said, she said problem, right? Like somebody's going to go and mess up the dashboard in a production environment, and then can avoid those pointing finger issues, right? With this approach, you clearly have a trail of who created the PR, who approved the PR, what is it really doing, and you also have an option to backtrace very quickly, fail very fast, which is not really possible if you're doing it using the ClickOps.
Gotcha.
For sure.
And one more. Go ahead, Mikhail.
Well, just one more thing about it is that I think one of the biggest benefits, other than obviously that it can be rolled back, we have traceability, we have approval processes, workflows that are driven by Git, is the fact that the customer doesn't need to even know anything about our observability accelerator. They don't need to even run this particular infrastructure as code through their pipeline or manually to make it happen. So they decouple themselves. So imagine doing it right from the infrastructure as code. There is a new dashboard, somebody comes in, they put it in, we make a run, affecting the production cluster in some way that is maybe a little bit detrimental and scary. And then it doesn't work. We go again, we fix it, we put it back in, we try to understand. And that saves a lot of those infrastructure as code runs and delegates that responsibility to the GitOps engine. Go ahead, Simon.
Right. Absolutely. I think that's related to what I was going to mention around configuration drift, where if someone were to go and mess with something in the UI, say, disaster strikes and your disaster recovery plan gets executed and your infrastructure automation gets kicked off, well, you might be missing some of those manual changes that were made in the UI. Your Git is no longer the source of truth. And that's really the essence of GitOps. Now, we did get a question in chat. And I'll say, this is a little bit of a spicy one. But how come AWS doesn't just build the Grafana features into CloudWatch dashboard? So I'll leave this question to any of you to answer, but I will start by saying that, well, we do to some extent. And features like container insights that we talked about earlier are helping us kind of close the gap. But I'll say that the way AWS approaches things like this is we build the things that customers are asking for. So whether it's Amazon Managed Grafana or the capabilities that we've been building in CloudWatch, it's a direct response to what customers are asking for. And right now, we are seeing that Grafana is rising in popularity, I think, with the open source ties and kind of the ability to plug with the number of different open source tools that customers may be using. But anything else that you guys want to add to that?
Sure.
Yeah,
So one thing, I mean, it is effectively a product management choice at the end. So so customers want to use Grafana, and we are customer obsessed. We want to address their request. Now it becomes a choice whether we take Grafana and build it into CloudWatch or dashboard, or we extend CloudWatch with this functionality, or it is presented as a separate feature. And because of the feedback that we're getting from the customers, and because of how we manage those teams, it's a very different skill set and a different tooling that is used to maintain open source Grafana within AWS and Amazon Managed Grafana versus our tooling that we use and programming languages and runtimes and build tooling, etc., that we use for CloudWatch. It just makes more sense to manage them separate. However, I hear requests that it may be beneficial or more intuitive for customers to discover the dashboards in the same common place. That may be actually shaped as a product feature request to create a more integrated view, regardless of how data is collected, being it CloudWatch or Managed Grafana or any other tool that we'll encounter down the road.
Yeah, and to add on what Mikhail is saying is, so customers also would like to use a single pane of glass to see all the data sources, right? And that is what we are trying to show here. Like if you see an example, the data sources that we created out of this 5-minute experiment, we created a Prometheus data source, we created a CloudWatch data source, and also an X-ray data source. So the idea here is that it doesn't mean it's CloudWatch, Grafana, it's just that what is the experience customer is wanting. And that is what this is all about, right? Like we created an experience where we have a single pane of glass with Grafana to see all the metrics and correlation and determine the observability strategy and extend their observability strategy for an organization.
Absolutely, and great question, by the way, and thanks for that answer, folks. I feel like we've distracted you enough here, Ela. Let's get back to the demo here.
Yeah, absolutely. So I think we are done with the first part of the demo, which is basically showing you an open source solution in 4 minutes or 4 minutes and 12 seconds, by the way. But I also wanted to show you an existing cluster that I created with AWS native pattern. Like as I said, right, we have tons of different choices customers would like to use. So we talked about open source pattern with using Grafana operator, Amazon managed Prometheus, AWS distro for open telemetry, and Amazon managed Grafana. But now we are going to flipping the coin into AWS native. So I already have a cluster that is up and running. It took me 20 minutes to create a cluster with setting up the AWS native observability. But if you have a cluster, and like me, if you want to set up an AWS native, it again is going to take less than 4 minutes. Let's see that cluster in action, right? So I'm just flipping the context to that cluster, the other cluster that I have in the environment. And if you see here, you can see the namespaces, you can see that CloudWatch is already set up, Metrics is already set up, I see a cert manager is set up, node exporter is set up. So in 20 minutes, you have a cluster created and all the AWS native tooling is set up to see your metrics and logs and traces out of the box with this particular solution. If I quickly jump into the code, and if I show you what this actually means, so if you take a look into this AWS native solution, and this is the code snippet, like what, 30 lines? All you have to do is spend writing 30 lines of code to set up an observability end to end in 20 minutes. It's not a joke. What I'm trying to say here is these are the things that has taken ages for our administrators or SREs to set up. So what we are doing with this solution is we are just using 20 minutes and we just have 30 lines of code to do this. So how this is possible is just because we are building all of these as using blueprints as the backbone, which Mikhail was talking about. So myself, Mikhail, and so many other contributors in our SA community, we just try to contribute to make these blueprints a larger ecosystem of solution so that we can build these wonderful patterns and solutions out of it. So what I'm trying to say here is, let's say you wanted to use CloudWatch logs. It's like 3 lines of code. Let's say I want to set up container insights, which I was pointing out, just 1 line of code. So you as a platform engineer just need to spend very little time to set up an entire ecosystem of environment to observe your Kubernetes environment. So this is with respect to the code that I was talking about. I'll highly recommend you to take a look into our GitOps repo to learn more. But with respect to limited time here, I'm jumping back into my console. I'm going to show CloudWatch in action right now. I'm flipping back into US East 1 region because, as I said, the other cluster that I'm running is in US East 1 region, which is basically using AWS native solution for observability. So as I flip in here, as I flip in the region, all I'm going to do is I'm going to go into container insights, and I'm going to go into container insights and select the cluster. The name of the cluster is single new EKS AWS native cluster. You can of course change the name to whatever you like, but I'm just using this name just to differentiate the patterns we have. And let's see, it's automatically showing all the resources. If you click on the resource, you see here, it's, by default showing you pod utilization, metric utilization, memory utilization, right? AWS Container Insights is doing all the heavy lifting for you to create these wonderful dashboards. But what you're seeing here is out of the box, you see the entire dashboards, which you can start monitoring in 5 minutes, right? Which in the past used to take a lot of time. And then you can also view the maps, right? You want to see a complete map of, sorry about the theme. Yeah, so if you want to see a complete map of what's happening, right? Like what is the different parts that you see here? Like what is the real map? Like what are the parts running and how is it correlating? You can see that view as well using the container insights. But again, within 4 minutes, you're able to set this up. It's really wonderful for an organization to get it up and running. Let's also take a quick peek into the CloudWatch logs, which again was a 3-line code that I showed you in the CDK in my VS Code. Let me I'm just going to show you some logs that is already being coming out. Let's see this Amazon metrics. This is one of the namespaces that I had in my cluster. So you're already seeing logs spinning up, like showing out of the box, right? Like you didn't do any kind of setup. You didn't set up Fluent bit. You didn't do any kind of CloudWatch exporter. None of those things is what we configured, but we did the code did the configuration. Like within 20 minutes, you can get it, or within 4 minutes in an existing cluster, the logs are flowing, the metrics are flowing, even if the workloads are having, if you have a workload which is X-ray instrumented, even the traces will be seen in traces console. So that is how much this solution is really powerful, right? So within 20 minutes, your observability is all set up. which will let you focus on building the infrastructure or building the necessary workloads for getting your business up and running, rather than focusing on this heavy lifting, which we are doing for you through this solution. So that's all with respect to demo side. Like, we have 4 more minutes, but this is exactly what I wanted to show: a combination of AWS native pattern and open source pattern, which I think folks can also learn from our solution. So this is the architecture of the solution that I just was showing you from an AWS native standpoint. But this is the ecosystem of solutions we have, and with the CDK Observability Accelerator.
Awesome. Thanks for that demo, Ila. So folks that are watching at home, we are getting ready to close out here. If you have any last minute questions, be sure to drop them in the chat. Really quickly, I do want to say that the team is building this in open source, and that's a very intentional design that we're building it in open source. We want your feedback. If you're watching this at home and you have a specific partner solution or a specific way that you want to use observability solutions, raise us a feature request. Actually, that is one of the things that I wanted to ask you folks as an open question. What if a customer is using, a third-party tool that's not covered in the accelerator today, a partner solution? Maybe they want to use Argo rather than Flux. What's Crossplane rather than Flux? What's the kind of options that they have available?
I can take that. So just as an addition, we are coming up with 2 new patterns, which is multi-cluster and multi-region patterns, and we are going to focus on Argo on that. We are not going to use Flux. So which means that we are going to bring in different flavors of patterns to this solution. It's not going to be single dimensional. We are also going to work with our partners like observability partners to bring in their patterns as well to this solution. So which means that this particular repository is going to be multi-dimensional. It is going to have different options which a customer can plug and play and choose for their observability needs. And also, right, if there is a customer, you are a customer, right, you have a specific observability need on EKS, you can also solve that with just one simple action that you can take, like go to our GitHub repo, just create a new issue, submit a feature request, and say what exactly do you want. Or if there is an existing issue that is already there, which is aligning to your needs, just go to the issue and just to upload the issue. We will be ready to work with you and create that solution and for you to use it up and running in your environment. So what we need is support from you, like start the repo, support us, contribute to us, and it's an open source solution. So that is what we are looking for from you out of this as a collaboration.
For sure, I can just add to that specifically, let's say, with respect to Crossplane, that kind of is moving away to a different set of patterns that we'll need to roll out. You can actually see an observability accelerator for Crossplane as a whole. That may be a separate flavor, and maybe the Terraform accelerator or the CDK component or blueprints can be just used to instantiate the initial management cluster with Crossplane setup, and then that's going to be the management cluster that will start provisioning observable clusters in other accounts, in other regions, etc. Those patterns will have to be worked out. We have the tooling now. You can surely use EKS blueprints to provision a management cluster with Upbound or Crossplane components, as well as ACK, AWS controls for Kubernetes, to enable that type of patterns for your organization.
Awesome. Thank you. Well, that's all the time we have for today. First, I want to end by thanking our guests, our AWS experts, for joining us. Thank you for watching from home. If you have any feedback, any questions, you can drop a comment here. You can drop a comment on the recording after the fact. And also, as always, be sure to subscribe to Containers from the Couch to catch more episodes like this in the future. Thanks, folks.
Thank you all.
Thank you.
Thank you.
Cheers.